I would suggest that you pause the video and try evaluating this function at to find g of -4a. So hopefully you substituted -4a into both of the values of x, and then once you simplified it, you should have gotten 48a squared plus 24a plus 7. All right, let's talk about section 2.8, which is the distance and midpoint formulas as well as circles. So quite a few objectives here. We're going to find the distance between 2 points. We'll find midpoint of a line segment. We'll write the standard form of a circle's equation. You're going to give the center and radius of a circle if the equation is given in standard form, and then you're going to convert general form into the circle's equation in standard form. All right, so let's refresh our memory on distance formula, because this is something that you should have done last year in geometry as well as probably in algebra. So it says the distance d between the points x1, y1, and x2, y2 in the rectangular coordinate system is, so d equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, so let's use that formula to then find the distance between each pair of ordered pairs. We'll round our answer to 2 decimal places if necessary. All right, so we've got the ordered pair 5, 1 and the ordered pair 8, 5. So it doesn't really matter which ordered pair you make what. So I'm just going to make the first ordered pair x1, y1, the second ordered pair x2, y2. But like our formula for the distance, underneath the square root, I'm going to subtract the x values. So x2 minus x1, and then that is being squared, plus, and now I'm going to do the same thing with the y's. I'm going to do y2 minus y1 quantity squared. Well, if I do order of operations, 8 minus 5 is 3, 5 minus 1 is 4, 3 squared is 9, 4 squared is 16. When we add 9 and 16 under the radical, that gives us the square root of 25, and that simplifies nicely to 5. So that is our distance. We didn't have to worry about rounding to 2 decimal places. In the next one, I'm going to label the first ordered pair x1, y1, second ordered pair x2, y2. All right, so when we're doing our distance, underneath the square root, we're going to want x2 minus x1. So square root of 7 minus 0, quantity squared. Plus, then I'm going to do y2 minus y1. So 0 minus negative square root of 2, quantity squared. So underneath the square root, our first parenthesis is going to simplify to the square root of 7, quantity squared still. Back-to-back negatives means that we're really adding here, but 0 plus the square root of 2 is still going to give us then the square root of 2, quantity squared. So when I'm squaring square roots, those end up canceling. So square root of 7 is quantity squared is 7. Square root of 2, quantity squared is 2. 7 and 2 is going to give us 9. And square root of 9 is another perfect square. It's going to give us a 3. Had that number been, 8, well, then we'd have to find 2 decimal places. All right, let's talk about the midpoint formula. Once again, this is something that you should have, this should be more of a review than anything. So it says, consider a line segment whose endpoints are x1, y1, and x2, y2. The coordinates of the segment's midpoints are, and then we want to add them together. So x1 plus x2 divided by 2, because that's what we're doing. We're averaging these. And then y1 plus y2 all divided by 2. So let's use that formula to look at a couple of examples. So I'm going to just, once again, label the first ordered pair x1, y1, the second ordered pair x2, y2. If I want to find then the midpoint, I'm averaging the x's together. So I want to add 1 and 7 and then divide it by 2. If I then want to find the y, I'm going to average them. So 2 plus negative 3, or just 2 minus 3, and then we'll divide that by 2. Well, 1 plus 7 is 8. 8 divided by 2 gives us 4. 2 minus 3 is -1, and -1 divided by 2, it'll just stay a fraction, so it's just -1/2. If I could reduce that fraction, that I would want to, but this is my midpoint. If I look at the next pairs, I've got the first ordered pair, x1, y1, second ordered pair, x2, y2. So once again, I'm going to be averaging these. So I'm going to take my x's, which is -2/5, and I'm going to add -2/5, and then I'm going to divide by 2. Then I'm going to take my y's, so 7/15, add that to the -4/15, and then divide that by 2. All right, so because we're dealing with fractions, the nice thing about these fractions is that they have the same denominator. So I'm going to be able to combine that into then -4/5. Here, let's do this. And then after I know that I'm going to be dividing by 2, that's the same thing as multiplying by the reciprocal. So the reciprocal of 2 is 1/2. Same idea with the y's. The nice thing about the fractions is that they both have a 15 for the denominator. So I get to add the numerators, which would give me 3. Still have it over 15, and then I'm going to multiply by the reciprocal. All right, I can multiply straight across here. So -4 times 1 is going to give me -4. 5 times 2 is going to give me 10. Over here, we're going to have 3 times 1, which is 3. 15 times 2 is 30. And then notice that both of these fractions we can simplify down. So -4/10 are both divisible by 2, so it's -2/5. 3 over 30 reduces down to 1/10, and here is my midpoint. Let's talk about circles. A circle is the set of all points in a plane that are equidistant from a fixed point, which we call the center. The fixed distance from the circle center to any point on the circle is called the radius. So the standard form of a circle, equation of a circle with center hk and a radius of r is the following: x minus h quantity squared plus y minus k quantity squared, and that equals r squared. So notice that my center, h and k, are technically represented as like positives, even though they could be negative numbers, but I'm always going to be subtracting them in my standard form equation. Okay, and then I'm always setting it equal to the radius being squared. All right, so we're going to write the standard form of the equation of a circle, given that the center is at -2, 5, and the radius is 4. So remember, the center is the ordered pair hk. So h is -2 and k is 5, and then my radius is r, that's 4. So I'm going to plug those numbers in. So we're going to have x minus, and then our h value, so -2 quantity squared, plus, then I want y minus k quantity squared, and that's going to equal our radius being squared. Well, back-to-back negatives, we have x plus 2 quantity squared. There's nothing to change or simplify in that second parenthesis. 4 squared is 16, so here is my equation of the circle, given my center to be -2, 5, and my radius to be 4. So let's look at this next one, same idea. 0 is going to be my h, k is going to be -6. My r value, my radius, is square root of 14. So we'll have x minus 0 quantity squared plus y minus -6 quantity squared, and that equals my radius, which is the square root of 14 quantity squared. In the first parenthesis, because we're subtracting 0, well, x minus 0 is going to be x. So we really don't even have to write the 0. We can just write that this is x squared. So if you ever just see a squared term, that means that you subtracted 0 from it. Here, we can simplify that second parenthesis. It's y plus 6 quantity squared. And the fact that the square root of 14 is being squared, the square and the square root cancel out, so that is going to equal 14. And here's my equation of the circle. All right, so now that we have an idea about our equation for a circle, now I'm giving you the equation. We want to work backwards. We're going to find the center, the radius, and then we're going to graph. And then once we have the graph, we'll use that to identify then the domain and the range. So remember, our h and our k value go with the x and the y, but I'm always subtracting those in the parentheses. So that means that my center, while I see h inside is a positive 3, I really subtracted it. And if I subtracted a negative, that's why that is plus 3 inside. So the h value is technically negative 3. And then since it's always y minus k, k is then positive 1. So essentially, if I'm giving you the equation, you are changing the signs from what you see in parentheses to identify that center. Since this 25 is technically my radius squared, I can create an equation where to get rid of a square, I'm taking the square root. Now, because we're talking about a radius, it is a length. You can't have a negative length. Normally, when you take the square root, you have two answers. This time I won't. My radius is just going to be the positive value. Nice thing about this is that it's a perfect square, so my radius is 5. So what I'm going to do to graph is I'm going to plot that center. So I'm going to go negative 3, positive 1, plot my point. And then from there, I know if my radius is 5, I want to go 5 away from that center in all directions. And the easiest ones to do on this coordinate plane are going to be going left, right, up, and down. So from the center, I'm going to go 5 to the right. 1, 2, 3, 4, 5, plot my point. From the center, I'm going to go up 5. 1, 2, 3, 4, 5, plot my point. From the center, we'll go 5 to the left. 1, 2, 3, 4, 5. From the center, we'll go 5 down. 1, 2, 3, 4, 5. And then we will just very carefully try to make it look nice and curved. We don't want it to look like a diamond. Okay, so just try your best to make it look like a circle and not a diamond. So there is my circle. And now that I have that, I can identify the domain and the range. So remember, to find the domain, we're looking at the x values. Well, it looks like the farthest on the left would be at negative 8, and it's included on the circle. So I want to bracket. Farthest on the right is a positive 2. It's also included because it's on the circle. I need a bracket. So negative 8, 2 is my domain. My range are the y values. Well, the lowest y value looks like it's negative 4. It's included because it's on the circle, so I want a bracket. Highest value is positive 6. It's on the circle. It's included. We need another bracket. All right, so we've talked about general form. So the general form of the equation of a circle is x squared plus y squared plus dx plus ey plus f equals 0. Because remember, general form, everything's to one side, it equals 0. In this case, D, E, and F are real numbers. All right, so I'm going to give you the general form, and we are going to rewrite this equation into the standard form. And remember, standard form is x minus h quantity squared plus y minus k quantity squared, and that equals your radius squared. So that's what we want it to look like. That's definitely not what it looks like right now. So what we're going to do is we're going to start by rearranging some terms. And essentially what we're going to have to do is we are going to be completing the square. But we're not going to be necessarily just completing the square once. We are going to have to do it multiple times depending on the variables that are given to us. So I'm going to rearrange this so I have the x squared term and the x term together. And then I'm going to leave a spot for me to complete the square because I want to turn those two into a perfect square trinomial to get it into that standard form. Then I'm going to do my y squared and my y term together, and I'm going to leave a spot for me to complete the square here. When I'm completing the square, remember, I always want my constant that doesn't have a variable over to the other side. So that's what we're going to do. We're going to add the 1 over to the other side. And so now it equals 1. But to keep the equation balanced, because I'm going to be completing the square twice, and I'll add 2 numbers onto the left, I got to add those 2 numbers onto the right as well. All right, so now that we have it set up, we're going to start by completing the square. I take the number that's in front of x, I'm going to divide it by 2, and I'm going to square it. 4 divided by 2 is 2. 2 squared gives me 4. So I'm adding 4, and let me do this in a different color. So we're adding 4 on the left which means we have to add 4 on the right. All right, now I'm going to complete the square for the y value. Notice that the number in front is -4. So -4 gets divided by 2, and we square that. Well, -4 divided by 2 is -2, but -2 quantity squared is still going to give us +4. So I'm adding 4 to the left, which means we're adding 4 to the right as well. All right, so now that we have this, I have 2 trinomials that are factorable. So x squared plus 4x plus 4, that factors into x plus 2 quantity squared. Because remember, the 2 is what we had in the parenthesis here prior to actually squaring it. So that 2 follows it down. Then I'm going to have to factor the y squared minus 4y plus 4. Well, that's going to give us y minus 2 quantity squared. The reason why it's a -2 is because we had a -2 in parentheses before we squared it, so that's why we brought that down. This is now going to equal 1 plus 4 plus 4. Well, 1 plus 4 is 5. 5 plus 4 is 9. So here is my standard form. All right, so I'm going to have you use this checkpoint problem. So pause the video, make sure you're completing the square in this equation to then get your standard form equation where you can identify your center and your radius to then graph the circle. And then once you've done that, you're also going to identify the domain and the range. So notice that in this case, I moved the 8 over to the right to get the constant. I rearranged my terms so the x's were together and the y's were together. Notice that I took 8 divided by 2 and I squared it. 8 divided by 2 is 4. 4 squared is 16. Because I added it to the left, I added it to the right. Then I have y squared minus 2y. So the -2 got divided by 2 and squared. Well, -2 divided by 2 is -1, but when I square that, I get +1. So if I added 1 to the left, I'm adding it to the right. Well, x squared plus 8x plus 16 factors into x plus 4 quantity squared. Y squared minus 2y plus 1 is going to factor into y minus 1 quantity squared. 8 plus 16 plus 1 gives us 25. Remember the center then, I'm taking those numbers and I am changing the signs because it's always x minus h. If I subtract a negative, that's why that 4 inside is positive. So my center is at -4, 1. I plotted my point there, took the square root of 25 to get my radius, and then I moved 5 to the right, 5 up, 5 to the left, and 5 down. Notice that my domain is the x's, so from -9 to +1, both those numbers are included because they're on the circle. My range goes from -4 to 6 because, once again, those are on the circle, so it's included in the range. So that was all of our information. We found the distance with midpoints. We looked at the standard form of circle. We can identify center and radius, and we can go from general form of a circle into standard form.